Well, how are you doing? To everyone in the Soundcraft UI 24 console group. This video is in Spanish since it's my native language. I apologize to people, to members from other parts of the planet. Well, I want to make the simplest explanation possible because there's actually very little information about this console and these failures. You could say, and how to fix them. Most comments in different groups simply say to send it for warranty or have the unit replaced through brand support. But let me tell you a bit about why this failure occurs and what the failure actually is. What failure, you might ask? The most common failure this console has is noise on the channels. It can randomly appear on one, two, several, or all channels. Noise that can be very subtle, so much so that it's not even perceptible audibly. But it does show up on the faders of the console's graphic interface. Or more noticeable noise that you can actually hear and can be quite annoying or completely disable the channel in some cases. All this started when I found a console at a very good price here in my country. And I bought it already having prior knowledge that very likely the preamps could have some type of damage. Due to misuse, perhaps connecting devices with phantom power activated or disconnecting cables with the gain open or the faders open. Things that happen in the audio world on different analog and digital consoles. Well, when the console arrived, I immediately started investigating the issue. Investigating in forums and different places where they mentioned the temperature problem that the console suffers from. Which is well known by everyone, that you should install a fan. And well, let me tell you that part of this problem stems from high temperature. In addition to manufacturing with components that perhaps aren't of the best quality. Or designs that aren't the most adequate, let's put it that way, on this board. Why do I talk about the design? Let's get into the matter. Here we have the image of the board from the front. I'm going to explain a bit how this board is composed in its different parts. Here below, in the lower part of the board, we can see the power supply lines. And this board is powered with plus, minus 16 volts. Apart from other voltages like phantom power supply, among others. But what interests us is the plus and minus 16 volt supply. And it goes to the preamps, which are these three integrated circuits that you see at the bottom. In these different lines, which are the 4580s, which are dual channel. That is, each line can handle two completely independent channels. Otherwise, we'd have double the circuits. That's why we have fewer. Because they handle two simultaneous channels. That's why I don't know if you've noticed, people who have had the channel noise problem. That most of them are in pairs, either next to each other or on adjacent channels. The problem repeats due to what I'm telling you. That the circuit itself is dual, it works on two channels. As I was saying, in the lower part we have the power supply and the lower capacitors. Each line of integrated circuits has its power supply line. Excuse the redundancy. That's why we can see capacitors grouped in different places. So it's not one main line that enters the entire circuit, but rather it goes in groups. The regulation of this voltage comes from the motherboard. This preamp board no longer does it. But the circuits are separated, with their respective filters, resistors, among others. The problem starts here. That is, for example, if we have problems on the right side in channels 17 and 18. To give an example, which was my case. What do we have to do to see if we have the power supply problem I'm telling you about? We have to look at the schematic of this JRC that we're going to see immediately. JRC 4580. To tell you a bit about how to do this test, which is quite easy. I'm doing all this because I found very little material, and it took days and days to understand the operation and the failure. Here we have the schematic of the JRC4580, and we can see that on pin number 4 and pin number 8, we have the voltage inputs, which is negative voltage and positive voltage. That is, at the lower left and upper right we have the voltage inputs. If we go to our board, we have to see that on the upper right pin and lower left we need to have continuity. Throughout the entire board line, independent of what I was saying, that below we have isolated lines for each group of amplifiers. These lines likewise have to have continuity. That is, if we measure the negative voltage pin of the last row. In the first row we have to have continuity on the tester, in the second, in the third, and in all of them. The problem comes here. Positive and negative voltage the same. Continuity. But if on line 18, as in my case, that is on input 17 and 18, we had noise. I noticed that on the negative voltage pin, I did have continuity. But on the positive voltage pin, it showed resistance. We could say there might be an open resistor, an open fuse, cold solder joints, which is also the case, but we'll get into that part. Measuring, doing different measurements, we can verify that the problem was in a resistor that's next to an inductor that acts as a fuse that's in the lower part. And we can see they're always in pairs. They're here, here. We can see another group there, another there, another there. You can see that the two fuses repeat, and I don't know if you can see over here. But next to these fuses we'll always have two resistors that continue in series with them. These 6-ohm resistors act as fuses in this case, and open their circuit when detecting some failure. As I mentioned in the channel, mine showed resistance, and it was because this lower 6-ohm resistor next to the inductors was open or practically open, not totally open. I replaced it, and I realized, you might say, why could a resistor have opened? It could be a failure due to material fatigue, due to temperature. But in the case of this channel it was due, let's go to the second image, to an integrated circuit that acts as a switch. This is the lower row. This row of integrated circuits, I don't have the number at hand, is an analog switcher that does the following. Of these 3 preamps that we have in a row, they are 3 levels of the preamp for each channel. The preamp knob of the channel is divided into 3 sections. We can say it's the initial one, the one that uses 1 preamp, the one that uses 2 preamps, and the one that uses 3 preamps. This design was done by the brand to reduce noise, since if you worked with a single preamp, by demanding more from this single one, we'd have greater noise as in other consoles. But here they decided to use a system of 3 preamps working together. So what does this row of lower switchers do? As we open the gain, the first third activates, the second third activates, the middle activates, the next preamp. That's the task of these integrated circuits we're seeing at the bottom. And the problem was that in the case of my console, one of these switchers died. It died completely, which caused, due to the obvious short circuit of the unit, the resistor to open. So what did I have to do? I had to remove the integrated circuit that acts as the switch and repair the resistor here in the lower part to have continuity in the power supply, like in all the preamp lines. With this, you might say, if this switcher doesn't work, the channel doesn't work. The channel does continue working, but at minimum gain. That is, we turn up the digital gain potentiometer and it doesn't do anything. We turn it up and it stays at minimum gain. The volume works correctly, but with minimum gain. It's like having a quarter of the gain. The channel is perfectly usable for some instruments, I'm telling you. To get by while the replacement arrives, the channel can continue to be used. In fact, I continue using it. So, that was the first failure. Let's say what caused the short in the resistor and the lack of voltage arrival. So, keep in mind, if you have a short in a power supply line, you have to check these switchers at the bottom. Many times, when they're bad, they show breakage. It's visual, you can see the breakage of the integrated circuit itself. That's one of the failures that occurs when we have noise in the channels, or the reason. The second option is also due to temperature. As you well know, the board heats up a lot. And therefore, the first measure taken is to resolder all these small transistors that you see in the upper part, SMD type. A proper soldering with flux is applied, and the board is cleaned thoroughly. With that, cold solder problems are ruled out. As I'm telling you, they occur in these SMD transistors in the upper part that are, let's say, in charge of handling the channel itself. The first input of the channel is handled by these SMDs prior to the preamp. And the other failure that can also occur, to continue telling you, that happened to me. And that was, let's say, the problem that caused noise in quite a few channels, in 6 channels, if I'm not mistaken, was that, effectively, I also didn't have continuity in another voltage, in another section of the board, if I'm not mistaken, in this third line. But this voltage didn't fail because the resistor was open or the switcher was burned. But it was due to an internal break in the power supply line of the board. That is, in this case I was getting 1.6 volts, where there should be 16. This I'm telling you is due to an internal break in the board, a fracture. It wasn't due to a short or failure of anything. And it was enough to make a jumper from the capacitor voltage point. In my case, I did it to the input of one of the preamps, of the 4580s, and that solved the problem. It showed stable voltage in all the preamp lines, and the noise completely went away. So we have to summarize. First failure, short in the switchers on this side of the board, which causes lack of voltage due to protection through cutting the resistor that's here below next to the inductors. Failure number 2, cold solder joints in the SMD transistors in the upper part. And third failure, fracture of power supply lines to the preamps. Well, this is oriented to users who have some experience in electronics. I don't claim to be a professional, but I understand practically, perfectly, let's say, this type of failure or how they can be corrected. On the internet, there's also quite a bit of information about schematic circuits. So, with a multimeter and some precision soldering, this can be corrected at home. I also recommend resoldering the connectors in the upper part. Here we can see them. These, the ones that go to the main board from the XLRs, I suggest resoldering them in the same way, as well as the SMD transistors adjacent to these connectors. To eliminate any doubt about cold solder joints, I recommend resoldering all this and cleaning the board very well with isopropyl alcohol. We resolder everything in a good cleaning. That would be the tips I can give you, and that's how I finally repaired 8 channels of this mixer that I was able to buy at a quite low price. And while it was a quite catastrophic failure, it's completely reparable.